Now we'll find out about the Sunday. NASA's historic Parker Solar Probe mission will revolutionize our understanding of the Sun, where changing conditions can propagate out into the solar system, affecting Earth and other worlds. Parker Solar Probe will travel through the Sun's atmosphere, closer to the surface than any spacecraft before it, facing brutal heat and radiation conditions, and ultimately providing humanity with the closest ever observations of a star. The Sun, at the heart of our solar system, is a yellow dwarf star, a hot ball of glowing gases. Its gravity holds the solar system together, keeping everything from the biggest planets to the smallest particles of debris in its orbit. Electric currents in the Sun generate a magnetic field that is carried out through the solar system by the solar wind, a stream of electrically charged gas blowing outward from the Sun in all directions. Though it is special to us, there are billions of stars like our Sun scattered across the Milky Way galaxy. The Sun at the heart of our solar system is a yellow dwarf star, a hot ball of glowing gases. Its gravity holds the solar system together, keeping everything from the biggest planets to the smallest particles of debris in its orbit. Electric currents in the Sun generate a magnetic field that is carried out through the solar system by the solar wind, a stream of electrically charged gas blowing outward from the Sun in all directions. The connection and interactions between the Sun and Earth drive the seasons, ocean currents, weather, climate, radiation belts and orrery. The Sun's volume would need 1.3 million Earths to fill it. The Sun is 93 million miles, 150,000 kilometers, from Earth. Its nearest stellar neighbor is the Alpha Centauri triple star system. Proxima Centauri is 2. The Sun, and everything that orbits it, is located in the Milky Way galaxy. More specifically, our Sun is in a spiral arm called the Orion spur that extends outward from the Sagittarius arm. From there, the Sun orbits the center of the Milky Way galaxy, bringing the planets, asteroids, comets and other objects along with it. Our solar system is moving with an average velocity of 450,000 miles per hour, 720,000 kilometers per hour. But even at this speed, it takes us about 230 million years to make one complete orbit around the Milky Way. 25 degrees with respect to the plane of the planet's orbits. Since the Sun is not a solid body, different parts of the Sun rotate at different rates. At the equator, the Sun spins around once about every 25 days, but at its poles the Sun rotates once on its axis every 36 Earth days. The Sun and the rest of the solar system formed from a giant, rotating cloud of gas and dust called a solar nebula about 4.5 billion years ago. As the nebula collapsed, because of its overwhelming gravity, it spun faster and flattened into a disk. Most of the material was pulled toward the center to form our Sun, which accounts for 99.8% of the mass of the entire solar system. Like all stars, the Sun will someday run out of energy. Scientists predict the Sun is a little less than halfway through its lifetime and will last another 6.5 billion years before it shrinks down to be a white dwarf. The Sun, like other stars, is a ball of gas. In terms of the number of atoms, it is made of 91.0% hydrogen and 8.9% helium. By mass, the Sun is about 76% hydrogen and 27.4% helium. The Sun's enormous mass is held together by gravitational attraction, producing immense pressure and temperature at its core. The Sun has 6 regions: the core, the radiative zone, and the convective zone in the interior, the visible surface, called the photosphere, the chromosphere, and the outermost region, the corona. Specifically, in the Sun's core, hydrogen atoms fuse to make helium. The energy produced in the core powers the Sun and produces all the heat and light the Sun emits. Energy from the core is carried outward by radiation, which bounces around the radiative zone, taking about 170,000 years to get from the core to the top of the convective zone. The temperature drops below 3.5 million degrees Fahrenheit, 2 million degrees Celsius, in the convective zone, where large bubbles of hot plasma, a soup of ionized atoms, move upwards. The surface of the Sun, the part we can see, is about 10,000 degrees Fahrenheit, 5,500 degrees Celsius. The surface of the Sun, the photosphere, is a 300-mile-thick, 500-kilometer-thick region from which most of the Sun's radiation escapes outward. This is not a solid surface like the surfaces of planets. Instead, this is the outer layer of the gassy star. The temperature of the photosphere is about 10,000 degrees Fahrenheit, 5,500 degrees Celsius. Above the photosphere lie the tenuous chromosphere and the corona, crown, which make up the thin solar atmosphere. This is where we see features such as sunspots and solar flares. Visible light from these top regions is usually too weak to be seen against the brighter photosphere, but during total solar eclipses, when the moon covers the photosphere, the chromosphere looks like a red rim around the sun, while the corona forms a beautiful white crown with plasma streamers narrowing outward, forming shapes that look like flower petals. Strangely, the temperature in the sun's atmosphere increases with altitude, reaching as high as 3. The sun itself is not a good place for living things, with its hot energetic mix of gases and plasma. But the sun has made life on Earth possible, providing warmth as well as energy that organisms like plants use to form the basis of many food chains. The sun and other stars don't have moons. Instead, they have planets and their moons, along with asteroids, comets, and other objects. The volume of space controlled by the sun's magnetic field is called the heliosphere. The sun's magnetic field is carried out through the solar system by the solar wind, a stream of electrically charged gas blowing outward from the sun in all directions. The sun doesn't behave the same way all the time. It goes through phases of its own solar cycle. Approximately every 11 years, the sun's geographic poles change their magnetic polarity. When this happens, the sun's photosphere, chromosphere, and corona undergo changes from quiet and calm to violently active. The height of the sun's activity, known as solar maximum, is a time of solar storms, sunspots, solar flares and coronal mass ejections. This space weather can damage satellites, corrode pipelines and affect power grids. A number of ancient cultures built stone structures or modified natural rock formations to mark the motions of the sun. This includes the sun and its effects on Earth and the solar system, as well as the conditions in space that future explorers will experience.